Here we go.
Good afternoon, everybody, and welcome to today's virtual brown bag session. Today we're going to talk about lab safety, and Ryan McAliney will be our speaker. He's the Regional Consultation Program Manager for OSHA's Dallas Regional Office, Cooperative and State Programs. Ryan started with OSHA in 2012 as an industrial hygienist in the Fort Worth area office. He moved to the Dallas area office in 2013 as an industrial hygienist. In 2021, he served on a roads detail as the Emergency Management Coordinator for OSHA Dallas Regional Office, Cooperative and State Programs Unit. In March 2022, he assumed the position of Regional Consultation Program Manager in the Cooperative and State Programs Unit for OSHA's Dallas Regional Office. He is also a certified industrial hygienist through the American Board of Industrial Hygiene Board of Global EHS Credentialing. And just some real quick housekeeping things before I turn it over to Ryan. If you have any questions, feel free to post them in the Q&A box at the top right-hand side of your screen, and we will go ahead and get those answered. With that, Ryan, please go ahead.
Good morning, everyone. I just wanted to say thank you for the opportunity to be here today and the privilege to present. Again, my name is Ryan McAliney. Today I'll be discussing the topic of laboratory safety and the OSHA standards that apply in a laboratory setting. So before we get too far into it, I'd like to kind of go over what OSHA is first. The Occupational Safety Health Act of 1970 established the Occupational Safety Health Administration in the Department of Labor. OSHA, or the Occupational Safety and Health Administration's mission, is to assure safe and healthful conditions for working men and women by setting and enforcing standards, providing training, outreach, and education, compliance assistance. Primarily, the Occupational Safety Health Act covers most private sector employers' workers, in addition to some public sector workers in the 50 U.S. States and certain territories and jurisdictions under federal authority. All right, so with that being said, the objectives of this presentation are going to be, we're going to discuss a general overview of OSHA standards that apply to laboratory safety, safety and health controls in your lab that your lab should have in place, how to protect yourself from common hazards when working, hazards found when working in labs, and how to find additional information regarding lab safety on OSHA's webpage. This here is a QR code to our OSHA Laboratory Safety Guidance webpage. It provides a lot of different information regarding OSHA standards and things like that. A lot of the information that I'll be covering today, it can be found here as well. So that's if you want to scan it, you can follow along with that as well. The next slide that we have here is why is lab safety so important? Lab safety is important because we want to prevent fatalities and injuries within laboratories. This is a CSB, Chemical Safety Board video. It's titled Experimenting with Danger. This is the intro to it, and so I'm going to go ahead and play it.
Accidents in research laboratories are not isolated events. Since 2001, the CSB has gathered preliminary information on 120 explosions, fires, and chemical releases at university laboratories and other research facilities around the country. The accidents have caused deaths, serious injuries, and extensive property damage. This CSB video reports on 3 laboratory accidents. The 2008 fatality at UCLA, a death by accidental poisoning of a highly regarded Dartmouth College professor in 1997, and a 2010 explosion at Texas Tech University, or TTU, that severely injured a graduate student.
It would be a shame if not every university stopped what it was doing whenever a major accident happens, like at TTU, like at UCLA, and take it as an opportunity to examine their own safety practices to determine what similarities there are.
The CSB investigated the Texas Tech accident, producing a case study that the board believes includes important safety lessons for academia as a whole.
The CSB is concerned with laboratory safety because it's an area that appears, in comparison to industry, pretty unregulated. There is an OSHA laboratory standard, but its focus is on exposure hazards and health hazards of the research work being conducted.
University research is a large and highly competitive enterprise. The CSB estimates there are over 110,000 graduate students and postdoctoral researchers working in academic laboratories across the U.S. Government agencies and private organizations spend billions of dollars sponsoring research at university labs. Academic institutions, principal investigators, and lab workers face significant pressures to innovate, achieve, and gain funding and recognition for their work.
Research conducted at university laboratories is often on the forefront of technology and innovation. It is important that this research continues and thrives, but it must be done within a strong safety culture where preventing hazards is an important value.
All right, so that video can be viewed at the U.S. Chemical Safety Board's Experimenting with Dangers webpage at www.csb.gov. I'm going to move on regarding the presentation, but that highlights why laboratory safety is so important. So each laboratory environment has different and unique hazards. Chemistry labs, engineering labs, physics labs, biology labs, they all have their own unique hazards and in different areas of research. So laboratory workers are exposed to numerous potential hazards, including chemical, biological hazards, physical hazards, radioactive, ergonomic, and other safety hazards. So let's start with biological hazards. OSHA's bloodborne pathogen standard requires employers to protect workers from infection to human bloodborne pathogens in the workplace. Employers must develop an exposure control plan and provide training to workers regarding bloodborne pathogens. The bloodborne pathogen standard also requires advanced information and training for workers in research laboratories to handle the HIV, human immunodeficiency virus, or hepatitis B virus, or other bloodborne pathogens. Just an FYI, October is National Biosafety Month, so as we go through this month, it's important to remember biosafety. Another standard that we're going to talk about that covers all of these types of hazards that employers and workers and students should be aware of is OSHA's Personal Protective Equipment Standard, which requires the employers to assess the workplace to determine what personal protective equipment is needed for workers. In addition, it requires employers to provide and pay for personal protective equipment whenever workers are exposed to hazards, such as biological, chemical, or other hazards that are listed on the screen here. Another example of type of personal protective equipment or standard that is necessary that we have is the OSHA's eye and face protection standard, which requires employers to ensure that workers use appropriate eye and face protection when exposed to hazards. Examples of that could be safety goggles, chemical goggles, face shields, etc. Another hazard that we're going to talk about, another standard that covers it, chemical and biological hazards along with radioactive, is OSHA's respiratory protection standard, which requires that a respirator be provided to each worker when such equipment is necessary to protect the health of the individual. In addition, OSHA has a hand protection standard, which requires employers to select and provide appropriate hand protection when exposed to hazardous chemicals or biological hazards. The reason why we discuss hand protection is typically found in chemistry or engineering labs. You'll find chemicals. Different chemicals have different breakthrough times in accordance with each type of glove commonly manufactured. So it's very important to understand the breakthrough time or the amount of time it takes for a chemical that, if it's volatile, to go through the glove. So what I always suggest is that you check the manufacturer specifications of the glove to make sure it's a good fit for your specific lab operation. In addition, when we talk about radioactive or physical hazards, OSHA has the ionizing radiation standard, which establishes limitations on exposure to radiation from atomic particles. In addition, certain lab operations can be loud. So OSHA has a occupational noise standard, which requires employers to develop and implement a hearing conservation program that includes the use of personal protective equipment. Example would be hearing protection or earmuffs if workers are exposed to certain noise levels above 85 decibels in an 8-hour working day. And then when we talk about other safety hazards here, OSHA has a standard which is called the Control of Hazardous Energy Standard, or known as our Lockout Tagout Standard, which establishes basic requirements for locking and tagging out equipment while installing, maintaining, or testing and repairing operations. The primary purpose of this standard is to protect workers from the unexpected energization or startup of machines or equipment or the release of stored energy. So when we talked about the video talked about OSHA's laboratory standard, or as it's formally known, the Occupational Exposure to Hazardous Chemicals in Laboratories standard, which requires employers to develop a chemical hygiene program. Each laboratory must designate a chemical hygiene officer and have a written chemical hygiene plan. The chemical hygiene plan must include provisions for worker training, chemical exposure monitoring where appropriate, medical consultation when exposures occur, criteria for the use of personal protective equipment, and engineering controls, and other special precautions for particular hazardous substances, and a requirement for a chemical hygiene officer to be responsible for the implementation of the chemical hygiene plan. In addition, when we talk about hazardous chemicals in the lab, OSHA has an air contaminant standard which provides rules for protecting workers from over 400 different chemicals from their airborne exposure. Let's move on here. So another standard that applies to laboratory safety is OSHA's Hazard Communication Standard, which is also known as HAZCOM, or the Right to Know Law, which is a standard that requires employers to develop and maintain a written hazard communication program for the workplace, including lists of hazardous chemicals present in the workplace, in addition to labeling the containers, and also in addition to making sure that safety data sheets are available to workers and to any downstream employers. If your laboratory uses a third party or anything like that, those need to be available to your subcontractors or temporary workers as well. And in addition, there's a worker training requirement that requires that employees be trained on the hazards of the chemical they work with. The next slide here. So when we talk about how do we control hazards that are in the workplace, what safety professionals use is a framework called the hierarchy of controls to select ways of removing hazards. These are types of measures that have been used to protect lab workers, including engineering controls, administrative controls, work practice controls, and personal protective equipment. When we look at this hierarchy of controls here, it's kind of like an upside down pyramid, basically. When we start at the top here, what we have is we have the most effective type of control going down to the least effective. So the most effective control that we can employ is to eliminate the hazard or physically remove the hazard from the workplace. For example, we have a really hazardous chemical. What we could do is we could choose to remove it from the laboratory environment if that's possible. Now, what I will say is that it's not always feasible to use all of these controls at one time. So what we try to do is we try to utilize the feasible in their order of most effective. So an example of substituting the hazard is maybe we would substitute the chemical for the less hazardous chemical that can work with our research, or we replace the hazard. Engineering controls are the next most effective, is where we isolate people from the hazard. Administrative controls is we change the way people work, and then the least effective, which is personal protective equipment. The reason why we say personal protective equipment is the least effective is because it depends on the worker's behavior to utilize the equipment. So the next thing we're going to talk about is some examples that are utilized in a laboratory setting. So for example, when we talk about engineering controls right here, we talk about a chemical fume hood, for example, in a laboratory, a biological safety cabinet. When we discuss working with, biohazards or pathogens that require certain isolation from our workers. Hazard warning signage, eye wash stations and emergency eye wash station or showers. An example of an administrative control that we talked about already is a chemical hygiene program, or developing standard operating procedures for chemical handling. How do we do a synthesis, or how do we complete this procedure safely? Another one is employee training, industrial hygiene monitoring, where we measure the amount of chemical within the workplace through laboratory methods. Medical examinations and surveillance for workers, sending them to an occupational health clinic to make sure that the chemicals that they're working with, they're not actually having symptoms of that chemical. Work practice controls are an example would be laboratory safety rules. A very common one is no mouth pipetting, chemical substitution where feasible. And these are some things that we talked about. Personal protective equipment we all know about. We know about respiratory protection, face shield, lab coat, chemical goggles, and disposable chemical gloves. So we'll move on to the next slide here in a second. All right. So when we talk about engineering controls, so the next part of my presentation is about how we can go about identifying if our laboratory is safe and do we have the right controls in our laboratories. So for example, engineering controls, as you can see here, are those that involve making changes to the work environment to reduce work-related hazards. These types of controls are preferred over all others because they make permanent changes that reduce exposure to hazards and do not rely on worker behavior. Here are some engineering controls that are in use in the laboratory. For example, chemical fume hood. Chemical fume hoods are utilized when doing any complex synthesis or reaction to draw air from the laboratory and to prevent or minimize the escape of air contaminants into the laboratory. So the idea of utilizing a chemical fume hood is to do your reaction here. There's usually ventilation that will then suck the air through, or the chemical gas or vapor through some air scrubbers into what we consider a pollution control device, or an air filtration device, typically, depending on the chemical contaminant. So that's an example of an engineering control. Another example is eye wash stations, which we have a picture of right here. Eye wash stations and emergency showers can be utilized by laboratory workers if a hazardous chemical spill occurs and gets into their eyes or skin. Here's the eye wash station, and then there's also a shower function that can be utilized. Now, the requirement to have one of these is usually with the type of chemical that you're working with, and it will usually be a corrosive item that will cause corrosivity to the skin or eye, and we want to verify that in the safety data sheet. Another example of an engineering control that we can utilize in a lab is, for example, commonly found in a microbiology lab or in a biology lab, is what we call a biological safety cabinet. Properly maintained biosafety cabinets, when used in conjunction with good microbiological sampling techniques, can provide an effective containment system for safe manipulation of moderate and high-risk pathogens or infectious agents. Now, of course, depending on the level of biosafety 1, 2, 3, or higher, depending upon the pathogen, the types of controls that you'll use in those will depend upon the actual infectious agent or the microbiological pathogen. And that will depend upon, the current ability to get pharmaceutical intervention, and then in addition, a vaccine, if there are vaccines available for treatment for that. So those biosafety levels are dependent upon the pathogen you're using and what risk you'll take with that. So, all right, so moving on, we'll move to the next slide. So when we talk about administrative controls are controls that modify workers' work schedules and tasks in ways that minimize their exposure to workplace hazards. As discussed already, minimize rotating workers through different areas for shorter periods of time, so they're exposed to less noise or chemicals. That can be an administrative control, or working with ways that minimize their exposure to workplace hazards. So typically in a laboratory environment, when we look at that, vapors and gases are sometimes utilized in an engineering lab to conduct an experiment, commonly used in chemistry labs as well. So when we talk about vapors and gases, they can be collected using several different sampling methods, including what we call here charcoal tube, and then also sorbent tubes or a diffusive air sampler, along with air sampling pumps. So basically what we want to do with this equipment, it allows us to evaluate the chemicals being utilized. So consider the approximate, before we implement any of these types of sampling devices, we want to evaluate the chemicals being utilized, consider the approximate quantities and utilization rates. For liquids, we want to consider factors of volatility, for example, boiling point and vapor pressure, and other physical properties of the chemicals that you're working with. Consider whether handling practices and engineering controls are being utilized that would increase or decrease your exposure or risk to the chemical. And then also we would want to determine whether exposure is likely to occur as a vapor or aerosol or its physical state. And then we also want to look at what personal protective equipment is being utilized by the worker. So once that's being said, once we determine that we're going to go ahead and take a sample using one of these different methods here. So we want to sample those individuals likely to have the highest workplace exposures. For example, the highest risk employees, due to the materials and processes in which they work, the conditions in which they work. For example, distance to exposure source and air movement, the tasks they perform, frequency of the tasks, and the way in which they perform the tasks, i.e. work habits and employee mobility. For example, a lab technician who leans over an open container during a reaction may have higher exposures than a lab technician who is not leaning into the rising plume of the air contaminant. Air sampling results are then compared to against what we call OSHA permissible exposure limits. OSHA permissible exposure limits are basically the legal air standard that you can be exposed to that chemical, and that will help us determine, are we selecting the right types of controls for the employee's exposure. So we'll move on to the next slide from there. So when we discuss work practice controls are procedures for safe and proper work that are used to reduce the duration, frequency, or intensity of exposure to a hazard. When defining safe work practice controls, it is a good idea for the employer to ask workers for their suggestions in developing these procedures, since they have firsthand experience doing the actual work. In addition, these pictograms here shown on this slide help remind employees what personal protective equipment and safe work practices are needed when working in a lab. General lab safety should be developed based upon the unique hazards encountered by workers in each workplace. Each lab is going to have different hazards. Physics lab, biology labs, chemistry, and engineering labs are going to have different hazards, which are based on the research or operation or procedure that's being conducted. Next slide here. Okay, so then we're going to talk about personal protective equipment. Personal protective equipment is protective gear needed to keep workers safe while performing their jobs. Examples of personal protective equipment include respirators, for example, an N95, face shields, goggles, and disposable gloves. Personal protective equipment is selected by the employer based upon the hazard exposed to the worker. All right. So as we get toward the end of my presentation, we're going to discuss where can employees find additional resources from OSHA. So workers have a right to a safe workplace. The Occupational Safety Health Act of 1970 was passed to prevent workers from being killed or seriously harmed at work. Employees who need to report an emergency, file a complaint, or seek OSHA advice, assistance, or other products, we ask you to visit our webpage at www.osha.gov, or you can call this number right here. It is a 1-800 number. It's 1-800-321-OSHA, and it allows you to leave a message for us regarding your complaint or an emergency or anything like that 24 hours a day. Or you can contact your nearest OSHA regional office, area office, or state plan office. We'll move on to the next slide here. Where can employers find additional resources from OSHA? So there's a couple what we call OSHA has. There's a few cooperative programs that OSHA has that are worth talking about here. So every OSHA area office in the United States has what we call a compliance assistance specialist. OSHA has compliance assistance specialists throughout the nation who can provide information to employers and workers about OSHA standards. Compliance assistance specialists can provide short educational programs on specific hazards or OSHA rights and responsibilities and information on additional compliance assistant resources. Contact your local OSHA office if you need additional information or would like to request help from one of our compliance assistance specialists. Now, OSHA has another program. It's our OSHA consultation services for small employers. The OSHA consultation service provides free assistance to small employers to help them identify and correct hazards and improve their injury and illness prevention programs. Most of these services are delivered on-site by state government agencies or universities using well-trained professional safety and health professionals. These programs are largely funded by OSHA and are delivered at no cost to the employers who request help. Consultation services are separate from OSHA enforcement activities and are confidential. To request such services, an employer can call or write the OSHA consultation program in the respective state. So in Texas, we have Texas, it's through the Texas Department of Insurance. OSHCON is the state consultation program that we have in Texas. So then the next thing that we're going to talk about is a cooperative and state program that we have. It's called the Safety and Health Achievement Recognition Program, or SHARP. Under the consultation program, certain employers, small employers, may request participation in this program. Eligibility for participation includes receiving a full service safety and health consultation visit, correcting all hazards identified by the state consultation program, and developing an effective safety and health management system. When we talk about OSHA's consultation service and the SHARP program, typically these are reserved for small employers that have 250 employees at the local at one site, or 500 corporately controlled within their organization. Another one that we have is OSHA's Voluntary Protection Program. And this is for more large employers. VPP recognizes large employers and workers in private industry and federal agencies who have implemented effective injury and illness prevention programs. Now, these two programs typically rely upon the employer. One of the requirements of these two programs, the SHARP and Voluntary Protection Program, is to ensure that the employer has an effective safety and health management system or injury and illness prevention program and maintain injury and illness rates that are below National Bureau of Labor Statistics averages for the respective industries. In VPP specifically, management, labor, and OSHA work cooperatively together and proactively to prevent fatalities, injury, and illnesses. OSHA has some other cooperative state programs for employers to reduce injury and illnesses as well. One of the ones that I'm going to highlight, in addition to the ones I've already highlighted, is the OSHA Training Institute Education Centers. The University of Texas at Arlington is one of our OSHA Training Education Centers, and they are they're a national network of nonprofit organizations authorized by OSHA to conduct occupational safety and health training to private sector workers, supervisors, and employers. So they're also a great resource on how to get training, identify hazards, and things like that. So at this point, I'm going to kind of open it to questions. Now, there's one other thing I do have to do before we get into the question and answer session, is to go over a standard OSHA disclaimer that I have to go over regarding question and answers. So this information has been developed by an OSHA compliance assistant specialist, or me, and is intended to assist employers, workers, and others improve workplace health and safety. While we attempt to thoroughly address specific hazards or topics, it is not possible to include discussion of everything everything necessary to ensure a health and safety work environment in this presentation. This information is a tool for addressing workplace hazards and is not exhaustive statement of an employer's legal obligations, which are defined by statute, regulation, and standards. This document does not have any force or effect of law. It is not meant to bind the public in any way. This document is intended only to provide clarity to the public regarding existing OSHA requirements under the agency or the law or agency policies. It does not create or diminish legal obligations under the Occupational Safety and Health Act. Finally, OSHA may modify rules related to interpretations in light of new technology, information, or circumstances to keep apprised of such developments, or to review information on a wide range of occupational safety and health topics. You can visit OSHA's webpage at www.osha.gov. So at this point, I'm going to introduce Roosevelt Shavers, who is my colleague, and we are going to have our question and answer session. All right.
Great. Thanks, Ryan, and welcome, Roosevelt. Just real quickly, before there were a couple questions here, but could you tell us about sort of what your job is? And like, I know that you started out as an industrial hygienist and now you've moved on to other things, but sort of talk about kind of like what an industrial hygienist is, what you do, and then what you do now as a regional cooperative or consultation program manager.
Yeah. Okay. So as an industrial hygienist, my job with OSHA was my formal title was a compliance safety and health officer, or my specialty was industrial hygiene. My job was to investigate complaints, accidents, emergencies that were reported to us by the public, and investigate, complaints and various topics that came up to conduct workplace safety and health inspections for OSHA. So I was a compliance safety and health officer for 10 years. I spent 10 years in the field investigating various, fatalities, accidents, bridge collapse, building collapses, various different topics, fatalities. That was, what I did. Now, an industrial hygienist is someone that basically specializes in identifying chemical, physical, biological hazards in the workplace. And we typically, what we'll use is industrial hygiene methods to collect evidence or to measure applicable chemicals, biological hazards, various things to help determine what the conditions are in a workplace. But specifically, industrial hygienists focus on biological hazards, radiation, chemical hazards, in a variety of industries. It could be from high-risk manufacturing facilities to construction, to general industry, to maritime, to all different types of industries. OSHA, anywhere there's someone working, OSHA can go and do a workplace inspection, and that was my job for 10 years. So personally, I've conducted almost, 600 to 800 inspections during my time frame as a compliance officer. Current Sorry, I kind of cut. I think my internet cut out there. So I'll get back to the question. So currently, my job is as a regional consultation program manager for Region 6, which I recently started. My job is to help manage the state consultation programs, which is OSHA typically gives a grant to our state plan partners, our state consultation partners. All 50 states have an OSHA consultation program for small employers. My job is to manage those programs. So Texas, Louisiana, New Mexico, Arkansas, and Oklahoma each have one. So it's one of our cooperative programs that we have at OSHA that can be utilized by a small employer to help identify safety and health hazards in the workplace and help correct them. And it's something that we utilize at the state level and typically through our grant process. So that's typically what my job is now. And
interesting.
Yeah.
Thank you. So what are the most common issues or hazards that you see, and maybe not you, but like say the broad you at OSHA that you would see on in a university lab or on a university campus that people should be aware of, and then maybe what are some of the common causes of that, or like I don't know if that. I guess answer the first part of the questions first, and that might answer the second part. Sure.
So I'll go ahead and answer that. So typically in a university lab, you're going to have, it depends on the area of research, right? So biology labs, typically what we have, we'll typically find you'll have biohazard lab, biosafety, depending on the pathogen that they have. In addition, we have what we consider bloodborne pathogen standard. A bloodborne pathogen standard covers typically it'll cover our, anything that is from other potentially infectious materials, which could be, HIV, HBV, or hepatitis B, the hepatitis B virus, Ebola, anything like that. OSHA does cover on a biological basis for various standards. We cover biohazards. We cover chemical hazards. So if you work in a chemistry lab, OSHA, we talked about OSHA's hazard communication standard. Those are typical common hazards that we find. Another one is OSHA's standard for laboratory safety, or laboratory safety standard. That covers what we consider our standard practices for a lab. Typically, we'll find some hazards related to that. Also, a common hazard is OSHA has, I believe, approximately 30, give or take 30, expanded health standards that we have. So depending on the type of lab, what we consider are regulated carcinogens. Those OSHA expanded health standards typically have a lot of requirements depending on the type, depending on the chemical that's used. Common ones are formaldehyde. Typically, formaldehyde is utilized in medical bacteriological labs or in pathology labs. So if your lab is at a medical school or just in the histology or the pathology arena, those typically have formaldehyde exposures. So any kind of organic vapors, those are very common hazards in the workplace. And what was the second part of that question, Jim?
I don't exactly remember, but I guess one of the sort of along with that, like the common issues and hazards, are there things that you see maybe in a college lab that you wouldn't necessarily see? So for instance, I know that you're not supposed to bring outside food and drinks into a lot of labs because some of them can get contaminated, or people get lazy about wearing goggles or gloves, or like what are some of the things that that happen often, maybe, or more often maybe in a college lab that people should be aware of and make an effort to avoid?
Yeah, so definitely things that people should be aware of is definitely following the lab safety rules that the college or university has. Following those, making sure that you do actively participate in the training and that you do listen, to the training and to the instructor. A common occurrence with that I've found related to just laboratory safety in general is a lack of a safety culture sometimes in a specific university or college to help support, that safety and health management system. So getting upper level leadership to buy into that and to provide the necessary resources is very important. In addition, also paying attention to the lab safety rules and getting all the workers trained that are necessary, or students, are common things that we find that they just didn't know that a chemical was in the lab, or they didn't know that was a rule. So definitely human factors is a big factor when we talk about safety. So hopefully that answers the question.
Absolutely. And so earlier in your presentation, you had Texas Tech and you had there was UCLA. There was a couple different universities mentioned and stuff. How common are accidents in university labs? Is it something that, because you can always point to the big things, and I'm not making light of any of this, but I just want to make sure, because if it is a pretty big problem, then I think people should understand that it's not just we're talking to them and telling them this, that these are real concerns that they do need to be aware of.
Yeah, so the CSB video that I showed, experimenting with danger, at the beginning had talked about since 2000, I think it was 2010, there had been, that their data had showed that there had been at least 120 incidents relating large issues with lab safety or accidents that they had been tracking. And they covered 3 incidences where there was and I believe some of those were related to fatalities or serious injuries, and they covered those related to this. But to answer your question, lab safety is very important, and I believe that video, I only showed a 2.5-minute clip of it because it highlights the importance of it. But if you wanted to go back and see it, it's a 25-minute clip from the Chemical Safety Board. But like anything else, lab safety, it just takes a few minutes or a few seconds of not paying attention, not following a rule, not using your personal protective equipment, or ensuring that a condition, if you know of a condition exists in your workplace, you should bring it to your manager's attention or your instructor's attention so they can correct it. It just takes one time for an incident to occur. And so that's what I'll say about that. Hopefully that answers the question, Jamie.
Absolutely. And I think underscoring what you said, I mean, it seems that I know UTA provides training and there are requirements for training and inspections and stuff like that. So kind of taking that seriously early on in your research career and learning how to do things correctly early on seems like it would make a big difference as you progress to maybe more dangerous things or maybe more involved things where, like if you learn your good habits early, then it's going to stick with you for the rest of your life, I guess. So that's all the questions we have. Is there anything else you'd like to add, or Roosevelt, is there anything you'd like to add before we sign off?
I just wanted to say thank you for the opportunity to be here, and I hope everyone that watches this video has a safe and healthy day. Great.
Thanks so much, Ryan. We appreciate your time. It's been very informative, and if anybody wants to watch this again later on, it will be posted probably within the next few days at go.uta.edu/COE-VBB. So hopefully we'll see you at the next one. You can see a whole schedule for the upcoming virtual brown bag series at that same email or same URL. Ryan, thanks again, and everybody have a great rest of your week. Bye-bye.
Thanks. Bye.